Lesson 5-8, multiplying polynomials. Now we multiplied a monomial times a polynomial in the last lesson. In this lesson we'll be multiplying two polynomials. There are two methods for multiplying polynomials. So first we're going to start with binomials. And then we'll work up from there. Now when we multiply two binomials, we have method 1, which is the FOIL method, and method 2, which is the table method. FOIL represents the order in which we multiply the terms. So FOIL is an order for multiplication. And the letters in FOIL tell us the order. They stand for first, outside, inside, and last. Method 2 uses a table, and the table works just like a multiplication table. So first let's talk about these terms, first, outside, inside, and last. Okay, if I have two binomials and I want to multiply them together, a plus b times c plus d. Using FOIL, we have first, and our first terms are the ones that come first in the parentheses, a and c. So we multiply those two together first. Then you have outside, and our outside terms are the ones that are on the outside of the parentheses. So we have a and d. Those get multiplied together next. Then you have inside, which are on the inside areas of the parentheses. So that gives us b and c. So those get multiplied together. And then you have last. And those are the last two terms in the parentheses. So that's b and d. So those will get multiplied together. Now when we put this together and we actually do it all at once, so I have a plus b times c plus d. And if I do this, I say first, outside, inside, and last. It makes sort of like a spiral pattern. If I come around like this, I end up back where I started. Some people also think of it as a heart. With a loop-de-loop in the middle. But that's the pattern using the FOIL method. So we're going to find a simple polynomial. We'll do 2x, or binomials, 2x plus 3 times 5x minus 6. Okay, and we're going to use both the FOIL method and the table method. Now the FOIL method uses the first, outside, inside, last. So first is 2x times 5x, which gives me 10x squared. Then outside, which is 2x minus 6, which gives me negative 12x. then inside, which is 3x, or 3 times 5x, which gives me 15x, and then last, which is 3 times negative 6, which gives me negative 18. Now following that pattern, we go in this order, first, second, third, fourth, and if we've done that correctly, our like terms will be in the middle. So I'll have 10x squared, negative 12x plus 15x gives me 3x minus 18. Now using the table method, we make a table, and I write one binomial across the top and the other binomial down the side, keeping the plus and the minus with the second number. And then I create a table. I have 2 terms, so I have 2 boxes or 2 columns, and I have 2 terms, so I have 2 rows. And this works just like a multiplication table. 5x times 2x gives me 10x squared. 5x times 3 gives me 15x. Negative 6 times 2x gives me negative 12x, and negative 6 times 3 gives me negative 18. With a table, when we multiply these out, our like terms will show up along a diagonal. So this top corner will always be our first term, and this bottom corner will always be our last term. Those won't have any other like terms, so they just get written down, and then we add our diagonals. Negative 12 plus 15 is 3, so I have 3x minus 18. As you can see, you get the same answer no matter which method you use. So it's a matter of preference whether you'd like to use FOIL or a table. Let's try another one. Okay, so I'll use FOIL and the table again. So FOIL gives me first, so that'll be 30x squared outside, so plus 18x inside, minus 50x, and then last, minus 30. So 30x squared, 18 minus 50 is negative 32x minus 30. Using the table, I'll write one term or one binomial across the top and one down the side, again keeping the sign with the second term. 5x times 6x is 30x squared. 5x times negative 10 is negative 50x. 3 times 6x is 18x. And 3 times negative 10 is negative 30. My like terms are in my diagonal. So I have 30x squared. 18 minus 50 was the negative 32x, and then minus 30. Now, either method seems to be equally simple for most people when you're talking about 2 binomials. But if we do a binomial times a trinomial, we have to do a modified FOIL. And it's no longer actually first, outside, inside, last. What happens now is I have to take my first term and I multiply it times each term in my second polynomial. Okay. Then I take the second term and I multiply it by each term in my trinomial. And so far it's not too terribly cumbersome, But you have to remember that the first term gets multiplied by 3 terms, and then the second term gets multiplied by 3 terms. With the table, you just add another row or column. So let's try that. We will do 2x minus 5 times 4x squared minus 10x plus 7. Okay, using the modified FOIL, I have 2x minus 5 times 4x squared minus 10x plus 7. So I'll do 2x times 4x squared, which gives me 8x to the third. Then 2x times negative 10x, which gives me negative 20x squared. Then 2x times 7, which gives me 14x. Then negative 5 times 4x squared, which gives me negative 20x squared. Negative 5 times negative 10x, which gives me 50x. And then finally, negative 5 times 7, which gives me negative 35. With this method, my like terms are not together. I have my negative 20 and negative 20x squared, and then I have 14x and 50x. So my like terms, I have to search for them. Negative 20 and negative 20 is negative 40. 14 and 50 is 54. And then minus 35. Now with the modified table, it's a little bit less cumbersome. I'm just going to move this a little bit, make it smaller. So I'm just going to pause and it'll magically appear. Okay, so the table doesn't need to be modified. We're still doing one term, or one polynomial and another polynomial. We just add an extra row or column. I'm going to put my trinomial across the top, but it really doesn't matter. I could go down the side. I have 2x times 4x squared, which gives me 8x to the third. 2x times negative 10x gives me negative 20x. 2x times 7 gives me 14x. Negative 5 times 4x squared gives me negative 20x squared. Negative 5 times negative 10x is 50x. And negative 5 times 7 is negative 35. We're doing all of the same multiplication. It's just a different setup. But with the table, again, my like terms will show up in my diagonals. So I don't have to go searching for them. They'll always be in the diagonals. Negative 20 and negative 20 is negative 40. 50 and 14 is 64. Write that down one. And then negative 35. So either one, again, works. You just have to make sure when you use the modified FOIL that you are getting each and every term. Let's do one more example of a binomial times a trinomial. So 7x minus 13 times 2x squared plus 4x minus 3. Modified FOIL. Okay, I have 7x times 2x squared, which gives me 14x to the third. 7x times 4x, which gives me 28x squared. 7x times negative 3, which is negative 21x. Negative 13 times 2x squared gives me negative 26x squared. Negative 13 times 4x gives me negative 52x, and then negative 13 times negative 3 gives me 39. So I have 14x to the third plus 28 minus 26 is 2x squared, and then negative 21 and negative 52 is negative 73x. plus 39. Using the table, every once in a while I have technical difficulties with this pen. Okay, 7x and 2x, 7x and 4x, 7x and 3, 13 and 2x squared, 13 and 4, and then 13 and negative 3. My like terms are showing up on diagonals. So I have 14 x to the third plus 2x squared minus 73x plus 39. So as you can see, we get the same answer, just in a different format. Okay, here's where I really start to have a preference, and that's if I do a trinomial or greater times another trinomial or greater. In these instances, I think a table is better because using the modified FOIL, if I do a trinomial times a trinomial, I have to keep track of A times D times E times F, and then B times D times E times F, and then C times D times E times F. And then if I go even larger, if I were to say do a trinomial, or well, maybe a 4-term times a 4-term, you have to go A times E, A times F, A times G, A times H, and then B times E, B times F, B times G, B times H, and then C times E, C times F, C times G, C times H, and finally D times E and F and G and H. And it can become cumbersome and very difficult to keep track of everything. If we're using just a table and I have these same two trinomials times each other, with the table I just add extra rows and extra columns. And if I want to make this a plus G, then I add another column. Or plus H, I can add another column. So it doesn't get as crazy keeping track of everything. But you can use either method. I just recommend the table because it helps you to make sure you've multiplied everything. Because if you forget to multiply something, you're going to have a big empty spot in your table. Whereas if you forget to multiply something here, you're having a list of terms written out, you won't necessarily catch it. So just be very careful if you use the modified FOIL on the larger polynomials. But let's try an example of one. Okay. Using the modified FOIL, again, you got to be really careful with this so that you don't lose track and not perform a multiplication. I'm going to do 3x squared times 2x squared, which is going to give me 6x to the 4th. 3x squared times 4x, which is going to give me 12x to the 3rd. 3x squared times 5 is negative 15x squared. Then negative 6 times 2x squared will give me negative 12x to the 3rd. Negative 6 times 4x will give me negative 24x squared. Negative 6x times negative 5 will give me plus 30x. 5 times 2x squared will give me 10x squared. 5 times 4x will give me 20x. And 5 times negative 5 will give me negative 25. We then need to identify any like terms. So I have two terms with a 3 as my exponent. So I have 12 and negative 12. These are actually going to cancel each other out. Next, I look for my squareds. I have negative 15, negative 24, and positive 10. So the negative 24 and the positive 10 will give me a negative 14, so that's going to give me a negative 29x squared. And then I have 30x and 20x, so plus 50x minus 25. Doing the same exact problem with the table, instead of the FOIL method, I would have 3 rows and 3 columns. Okay, so I'm going to get 6x to the 4th, 12x to the 3rd, negative 9x squared. I must have written that down wrong. I wrote it down as a 5, didn't I? Okay, well, we'll turn it into a 5 so that it works and we get the same answer. Let's make that a 5, so negative 15x squared. And then negative 12x to the 3rd, negative 24x squared, negative 30x, 10x squared, 20x, and negative 25. My like terms are still going to show up on the diagonals. So I have 6x to the 4th, negative 12 and positive 12 cancel. 10 minus 24 minus 15. 20 and negative 30. And then negative 25. So the table method actually was more accurate for me because I see that I made a mistake on my signs somewhere here because I got a 50 here before, not a negative 10. And it should be a negative 10. So, as I said, for longer ones like this, I actually prefer the table method. But you can use any method, and this is how you multiply your polynomials.